So we continue with lesson one. We are now looking at right angled triangle or right triangle, right angled triangle. Like I said, we are looking at two things, Pythagoras' theorem, and then we are looking at trigonometrical ratios. So let's start with Pythagoras' theorem. Pythagoras is actually someone's name. He says that whenever you have a right angled triangle, what is a right angled triangle? A right angled triangle is a triangle which has one of its angles measuring 90 degrees. A triangle that has one of its angles measuring 90 degrees. So the small square you are seeing there means 90 degrees. He says if you have a right angled triangle, square of the hypotenuse, that's the correct pronunciation, but I'll be using hypotenuse, okay? Square of the hypotenuse should be equal to square of AB, which is known as perpendicular height, plus square of AC. BC, right? Square of AC should be equal to square of AB plus square of BC. In other words, if you want to know the hypotenuse, add the square of AB to the square of BC, and that will give you the square of AC. So like I have here, AB squared, which is this side, plus BC squared, which is this side, the base. So the AB is the height, BC is the base, should be equal to AC squared, which is the hypotenuse. So if you want to know the hypotenuse, what do you do? The form is saying that we are looking for the hypotenuse, but his theorem is saying that we should get the squares there. You can't remove it. It's someone's thing. You can't say, oh, the squares for everyone is here, here, and there. Let's remove it. No, you can't remove it. So he says that if you want to find the hypotenuse, don't ignore the square. So it becomes the hypotenuse squared should be equal to AB squared, which is the perpendicular height squared, plus BC squared, which is the base squared. I have another diagram here to show you that the triangle could be turned in any way. If it is turned like this too, still these are hypotenuse, okay? These are hypotenuse. So it's very important. Now, if you check, the 90 degrees actually touches two lines. So the 90 degrees here is touching line AB and line AC. But it's not touching one line, which is the AC. It's touching line AB and line BC. But it's not touching line AC. That means the one that the 90 degrees doesn't touch, that is our hypotenuse. If I come down, the 90 degrees is touching line AB and line BC. But it's not touching line AC, so our hypotenuse is line AC. The question I'm saying that because sometimes it can be difficult seeing the hypotenuse. So an example, let me do this. Good. So immediately I see this, that is a right angle triangle because of the 90 degrees. Okay. Now, if you check which one is the longest, hypotenuse is always the longest. So which one is the longest? So don't worry. The 90 degrees is touching two lines. It's touching this and this. The one that the 90 degrees doesn't touch is the hypotenuse. So our hypotenuse is this one. All right, the one with the blue. So it's very simple. All right. Good. So let's move on. Now, before we move on let's also note that it's not always that it will be A, B, and C. Okay. It could be any letter at all. M, N, O, P, Q, R, any letter. And then the letters could also be turned anyway. A can be here, B can be here, C can be here. If it is like this, then it becomes still height squared plus base squared equals hypotenuse squared. So this one, if I have A, B, C arranged like I've used the red, then that will become AC squared. You get it? Now our height is AC. AC squared plus AB squared should be equal to BC squared. Are we there? So whichever way it is arranged, know that you have to go like that. The height squared, or the perpendicular height squared, plus the base squared is equal to the hypotenuse squared. All right, good. Sometimes too, you will not get the vertices being labeled, the tops. You will not get that. You will get small letters at the middle. So let's say A here, B here, and then C here. Right, that means same thing. The height squared, B squared, plus the base squared, A squared, is equal to the perpendicular, the hypotenuse squared. So height squared plus base squared equals hypotenuse squared. You can also start from the base because addition is commutative, all right? But it's important to know the AC, to know your hypotenuse, very important. Right, that being said, let's delve into it. So, for example, if I have this triangle, okay, and then this side is, which side should I use first? I have the base to be 3, and then I have the height to be 12. Or 12 blue? Yes, the height is 12. And then I'm asked to find this one, let's say x. Okay, Pythagoras' theorem is saying that to find this hypotenuse, what are we going to do? We are going to have square of the height, so 12 squared, plus square of the base, 3 squared. Okay, that should give us square of the hypotenuse, x squared. So 12 squared plus 3 squared equals x squared. Like I said, you can start with the base too, so it can be 3 squared plus 12 squared equals x squared. You can't start with any one at all. The base and then the height could be interchanged, but important to know your hypotenuse. Okay. All right, so over here, x squared is equal to 12 squared plus 3 squared, or 12 squared plus 3 squared equals x squared. Okay, so now what does it become? I've cleared everything. Oh, no problem. What does it become? We said 12 squared plus 3 squared is equal to x squared. 12 squared is what? 144. Am I right? Yes. And then plus 3 squared. 3 squared is what? Is 9. That should be equal to x squared. 144 plus 9. 144 plus 9. What do we have? That is 153. That's equal to x squared. We are looking for x, not x squared. Okay. If it had been 2x, we divide by 2, but this one is x squared. Right? X squared. So what do we do? Squared. You can hear the name squared. So we apply the square root sign. So square root of 153 is equal to square root of x squared. So we have square root of 153 is equal to square root of x squared. Now the square will cancel the square roots. Okay, square will cancel square roots. I just told you that already. The square root means exponents half. Exponents half. So square will cancel the square root. You look at that maybe in one separate video. Square roots will cancel the square. Now we have what's left? X. X is equal to square root of 154. Then you add the centimeters, meters, whatever units that you'll be given. So the x, that means the hypotenuse is square root of 154. So when you use your calculator, whatever you get decimals actually, because this will not give you a perfect number. We know square root of a number means what number will multiply itself to give you the number you see under the square root sign. Now, this will not give you a perfect number. You get this. Now, imagine the diagram. I used 5, 12, and x. In that case, it will be 12 squared plus 5 squared equals x squared. Is that not it? So if you use that, we are going to get a perfect one. So 12 squared plus 5 squared is equal to x squared. All right, now 12 squared is 144, and then 5 squared is what? 25. That should be equal to x squared. So we have 144 plus 25 equals x squared. 144 plus 25 equals x squared. 144 plus 25 is 169. That is equal to x squared. So again, we are looking for x, not x squared. So what do? We apply the square root sign at both sides. So 169, square root of 169, square root of 169, square root of 169 is equal to square root of x squared. All right, now squared will cancel the square root. Now square root of 169, square root of 169. That means what number will multiply itself to give you 169? That is 13. 13. So our x is 13. So in the question, our hypotenuse, our hypotenuse is 13. So now that we've known the Pythagoras theorem, let's now look at the next one. Let's now look at the next one, which is trigonometrical ratios. All right, trigonometric ratios or trig ratios. Trigonometric ratios or trig ratios. Now, you've heard of SOHCAHTOA. So that one also deals with right-angled triangle. So if you have right-angled triangle, but this time with an angle other than the 90 degrees. So we said with the Pythagoras theorem, immediately it is right-angled triangle. You can use it. The height squared plus base squared equals hypotenuse squared. But with the trigonometric ratios, we are saying that there should be an angle at least. There should be one angle apart from the 90 degrees. The 90 degrees is constant because that is what makes it right-angled triangle. But there should be another angle. It could be here or it could be here. All right. Anyone is fine. So there should be an angle. So the theta I have here, the symbol I have here is theta. It's a Greek letter. It's theta, which symbolizes an angle. Right. Now you've heard of SOHCAHTOA. SOHCAHTOA. Your teacher has mentioned that to you. SOHCAHTOA. If your teacher hasn't mentioned, then let's look at it. SOHCAHTOA. Now the SOHCAHTOA is just an acronym that we use to remember the trigonometric ratios. I've used white for the S, C, and T. SOHCAHTOA. Look at the spelling well. SOHCAHTOA. SOHCAH and then TOA. So the white ones actually represent something specific which has connection with the angle. The white ones are representing the angles, and then the red ones are representing the sides. The red ones are representing the sides. So we know our hypotenuse from the first part. We know that this is our hypotenuse, right? Then this is our base, and then our perpendicular height. But under trigonometric ratios, we are not going to use the same names, but then the hypotenuse actually is the same. the hypotenuse is the same, but apart from the hypotenuse, the rest of them will change. So this side here, the BC becomes our adjacent. Okay, the A, that is the A, adjacent. Then the AB here is our opposite. Okay, opposite. Then like I've said, this is always our hypotenuse. The AC here is our hypotenuse. The adjacent and then the opposites are not constant. The adjacent and the opposite are not constant. So over here, we are using the angle to tell which one is our adjacent and which one is our opposite. So let's take our time and look at this very well. So we have an angle here. Now the angle is, there are 3 lines here. 1, 2, 3. A triangle has 3 lines, right? The angle here is facing a certain line. It's facing, okay? So if you look at it, there's the angle, it's facing this line. Can you see it? It is facing that line. So that's the opposite. I am facing you like this directly. So that's opposite. So because the angle is facing line AB becomes our opposite in this diagram. You get it? Good. So if line AB, so now let me go this way. Sorry for the noise. There's going to be some noise at the background. Sorry for that. Okay. Yeah. All right. So if line AB is our opposite, because that is the one that is facing the angle, the theta, and then we already know our AC is the hypotenuse. Okay. Then obviously the remaining one is our adjacent. You get it? So adjacent. So the adjacent is the one the angle is sitting on it. But that one, let's not move much into it, because some students, when you tell them the line the angle is sitting on it, okay, they get confused because they are looking at the hypotenuse. Because the angle, actually theta, is touching the base and then the hypotenuse, right? So when you tell them the angle, the line the angle sits on it, then some people might be thinking about this. It's actually this one. So in other words, don't worry. Look at the angle, that's the line, that's the angle which is the theta is facing. So in this case, we are saying that theta is facing AB. So that is our opposite. We already know our hypotenuse already, right? That is the one that faces the 90 degrees. So automatically the last one becomes our adjacent. So our opposites, our hypotenuse, and then our adjacent. So can you see something? OAH. Okay, so OAH. So now let's see something here. OAH. Look, O here. So there is O here. There is A here. Another A here. And then H over here. Can you see? So now you can see all the letters are gone. So OO, we have AA, and then we have HH over there. Can you see? And then the SCT, I said those ones are something constants that we have in maths. Okay, we are going to look at their names, and they mostly go with the angles. Right? So let's go back and see something. Let me clear my board, and then we look at something. So imagine the diagram is changed like this. The diagram is turned like this. All right, it's turned like this. Same thing. Let's look our adjacent. Where do you think the adjacent is? Yes, you are right. So that is here. Where is our hypotenuse? Here, we already know it. Where is our opposite? It's here. Okay, if you think you'll be confused, you just go this way. Look for if you think you'll be confused, you know your hypotenuse, so look for your opposite next. So you know that this is hypotenuse because it's facing the 90 degrees. Now look for your opposite, then the remaining is your adjacent. So we've said the opposite is the angle that faces the line that faces the angle. The opposite is the line that faces the angle, which is the theta. All right. So let's clear the board and look at another thing. Look at this. I have this diagram here. Okay. Now let's look at, we know our hypotenuse. Yes. So hypotenuse here, that's the longest, or the one facing the 90 degrees. So we are left with the adjacent and then the opposite. Let's look for our opposite first. So this is the theta. The theta. So you can see it's facing AB. So AB becomes our opposite. Then obviously AB becomes our adjacent. All right. That is that. Let's look at this one too. So this one, get your hypotenuse. Yeah, that is right. AC. Okay, let's forget the adjacent now. Look at the base. The opposite. Let's look for our opposites. Again, draw the line that I drew, okay? From the angle theta to the line. So the angle theta is here, right? So which line is it facing? Let's continue with it. Good. So AB is our opposites. And then automatically BC becomes our adjacent. So I hope we are seeing how to find them, right? Good. Now let's continue. Look at this one. Now look at where the angle is found. It's now found at the top. Is now found at the top. So which one becomes our hypotenuse? Always hypotenuse first, then we continue. So our hypotenuse is this, the longest one, the one facing the 90 degrees. The one facing the 90 degrees. Then we go our opposite. So look for opposite, and automatically what is left is our adjacent. Our opposite. Okay, let's see. This is our theta, right? Let's continue with that line. Okay, so our opposite is what? Line BC. Then automatically our adjacent becomes line AB. Are we together? Good. So now that we have been able to identify them, let's move on. So this one too, our hypotenuse. Look for your opposite. Yes, you are right. And then adjacent is this. Okay. So now, before we solve the question, that is it. Now, so the trig ratio is what I've done here. It says that sine theta is equal to opposite over hypotenuse. So now we know our opposite, we know our hypotenuse. Sine theta is equal to opposite over hypotenuse. I'll talk about it, don't worry. Then we have cos theta. So the S here, so in our SOHCAHTOA, the S is what? Sine. That's the spelling is S-I-N. S-I-N-E rather. But then we write the short form S-I-N. S-I-N-E. So sine theta, the theta represents the angle like I've said. Sine theta is opposite over hypotenuse. Then we have the C represents cos, that is cosine. But then we just use the short form. So cos theta is adjacent over hypotenuse. That's why we're identifying the opposite, the adjacent, and then hypotenuse. Then the T is tangent, okay? So we just put a short form. We say tan. So tan theta is equal to opposite over adjacent. Opposite over adjacent. So imagine, let me go to my first diagram. So imagine we have this, okay? And then our theta, let's say the angle for our theta is 20 degrees, okay? 20 degrees. So our theta is 20 degrees. In place of theta, you have 20 degrees. Okay, so where you see theta in the trig ratios. So this is what we call the trig ratios, okay? Trigonometric ratios. Ratio means division. So opposite over hypotenuse, that's for sine theta. Adjacent over hypotenuse, that's for cos theta. Opposite over adjacent, that is for tan theta. So if the angle is 20, then where you see the theta, you put 20. So in that case, we are going to have sine 20 degrees is equal to opposite over hypotenuse. You get it? And then we will have cos 20 degrees is equal to adjacent over hypotenuse. And then we will have tan 20 degrees is equal to opposite over adjacent. Are we getting it? Good. Now, someone will be asking, cos 20 degrees, what is? You just use your calculator, okay? But it's because it's something constant. But because you and I are not going to use calculator in the exam room, the question will do you the honor, the justice of giving it to you. So the question can tell you that tan theta is this, cos theta is this, tan 20 is this, cos 20 is this, sin 20 is this, okay? The question will give it to you. All right, good. So now the next thing is to know which one you are using. Are you using the sin 20, cos 20, or tan 20? If you should check well, you realize that each of the ratios has two sides, opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent. So we need two sides. So imagine the question gave me this side 3 and this side 5. Which one am I going to use? And then again, we are assuming the angle is 20 degrees. So look at it. Which one are we going to use? Relax. So we have our hypotenuse. Are we there? Given. We know that our hypotenuse has been given. Are we together? Good. And then which side again has been given? Look at the angle. There's the angle. The angle is here. Let's continue. So the 5 becomes our opposite. Since the angle is facing the AB, the 5 becomes our opposite. So you have been given hypotenuse, which is 3, and opposite, which is 5. We go to the ratios to ask ourselves, which one has the hypotenuse and opposite? We are going to use the ratio that has hypotenuse and opposite. So let's see. This one has hypotenuse and it has opposite. Can you see that? The sine has hypotenuse, it also has opposite. So we are going to use sine 20 degrees is equal to opposite over hypotenuse. Are we there? Good. And then that's going to be sine 20 degrees is equal to, what is our opposite? Our opposite is 5. 5 over hypotenuse, which is 3. You get it? Then you solve. But because we don't know sine 20, we have to use our calculator. The question will give it to you. All right. Good. Now imagine the question gave us this side, let's say 2 here. Still, we are taking our theta to be 20. And then it gave us this side, let's say 4 here. What are we going to do? We know our hypotenuse, that is 4, right? So let's look for our other side. So we know hypotenuse here. Which one is our base? Adjacent, and which one is our opposite? Yes, you are right. This is our opposite, and then this is our adjacent. So look, which ones have we been given? You have been given 2, adjacent and hypotenuse. Good. So we are going to look for the formula that has, or the ratio that has adjacent and hypotenuse, and that is what? Cos. So cos theta has adjacent and hypotenuse. That is the formula we are going to use, or the ratio we are going to use. So it's going to be cos 20 degrees is equal to 2 over 4. Because our adjacent is 2, our hypotenuse is 4, and then we solve. All right, so similarly, if assuming we were given this side, let's say 3, and then we're given this side to be 5. All right, which of the ratios are we going to use? Are we going to use sine, cos, or tan? You see, so now based on the size that you'll be given, okay, based on the size that you'll be given, that's where you either ask, so katwa, are you using so, or you are using ka, or you are using TOA. You get it? That is why. So the SOCA TOA is just the acronym to tell you. So SOH. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, and then TOA is opposite over adjacent. So sine theta opposite over hypotenuse, cos theta adjacent over hypotenuse, and then tan theta opposite over adjacent. I just use the white for the trig, okay, the T angles. So over here, which one are we going to use? All right, so first, you know your hypotenuse, right? So hypotenuse. Find the opposite. So opposite is 3. So these are adjacent. Which ones have you been given? Opposite and adjacent. So we are going to use TOA. Very, very, very simple. Okay. All right. So now let's look at a question.